Hi students, as per the request made by one of my beloved subscriber Kirti, so today I am going to make the video on polyurethane. So in this particular video I am going to explain the preparation or synthesis of polyurethane conceptually. So polyurethane, the name itself suggests that it is the polymer. It is the polymer. Now, what is the most toughest job while writing the preparation or synthesis of any of the polymer? The toughest job while writing the preparation or synthesis of any of the polymer is remembering its monomeric units, remembering its starting materials. Now, in order to remember the starting materials or the monomeric units required for the preparation or synthesis of polyurethane, I have framed one word for you. So if you remember this word, it is very easy to remember what are the starting materials or monomeric units required for the preparation of polyurethane. So that particular word by which we can remember what are the starting materials or monomeric units required for the preparation of the polymer polyurethane is mu. So if you remember this particular word, it is very easy to remember what are the monomeric units or starting materials required for the preparation or synthesis of polyurethane. So mu. So just remember the word mu, M-E-U. So if you remember this word, it is very easy to remember the monomeric units of this particular polyurethane. So in this mu, M stands for methylene. M stands for methylene diphenyl, diisocyanate, and E stands for ethylene glycol. E stands for ethylene glycol. Whereas the U stands for our polymer, that is polyurethane. Right. Now, it is very clear with this particular word that the starting materials are monomeric units required for the preparation of the polymer, which is so called as polyurethane, is one monomeric unit is methylene diphenyl diisocyanate, and the second monomeric unit is ethylene glycol. Now let us see what is the structure of methylene diphenyl diisocyanate and what is the structure of ethylene glycol. This is the second task rules. How to get the structure. There is no need to memorize the structures. There is a concept behind the structure of any of the molecule, any of the compound. So if you remember conceptually, then it is very easy to remember the structure of any molecule or any compound. Now, methylene. So, one moiety is methylene here. Methylene. So, methylene means CH2 students. Methylene means CH2. So, do remember that CH3 is methyl. CH3 is methyl. So, you can yes, you can remember this also. CH3 means methyl. CH2 means methylene students. CH2 means methylene, whereas CH means methyl. CH means methyl. So you have to remember this, right? Now, what is the moiety? One of the moiety present in this one of the monomeric unit, methylene. So, CH2. So, methylene. And the second one is diphenyl. So, diphenyl. Phenyl means what, students? Phenyl means this moiety, benzene moiety. This is the thing. And isocyanate. What is isocyanate? Isocyanate is N double bond C double bond O. N double bond C double bond O. Right? So methylene means CH2, phenyl means benzene moiety. Just remember that. Isocyanate means N double bond C double bond O. Right. Now, the second, what is the second one, students? Ethylene glycol. So how to remember the structure of ethylene glycol? So in order to remember the structure of ethylene glycol, you have to remember the starting material by which the ethylene glycol has been derived from. That starting material by which the ethylene glycol is derived from is ethane. Ethane. What is ethane? CH3. This is ethane. This is the most familiar structure. Ethane. Now what I am doing is, instead of writing CH3, I will write CH2H. I am just elaborating the structure. That's it. Instead of writing CH3, I am writing CH2H, and I am elaborating here also CH2H. Now, if these two hydrogens from two carbons are replaced by hydroxyl groups, if these two hydrogens from two carbons of ethane are replaced by hydroxyl groups, then the ethane structure will convert to ethylene glycol. Now, accordingly, what is ethylene glycol, students? CH2OH. Next, CH2OH. So this is how you have to remember the structure, but don't memorize the structure. Don't memorize the structure. So one of the monomeric unit is methylene diphenyl diisocyanate. What is methylene? What is phenyl? What is isocyanate? Already I have explained. And I have given the structure of ethylene glycol. How to remember the structure of ethylene glycol? In order to remember the structure of ethylene glycol, you have to know what is that molecule from which the ethylene glycol has been derived from. The ethylene glycol has been derived from the ethane. Now, how to get the structure of ethylene glycol from ethane? What do you need to do? CH3 is ethane. Now, what we need to do is, we have to elaborate the structure as CH2H. If the two hydrogens from two carbons of ethane are replaced by two hydroxyl groups, then that particular molecule is ethylene glycol, which is the second monomeric unit required for the preparation of polyurethane. Now, what is the first monomeric unit, students? Methylene diphenyl diisocyanate. Methylene. What is methylene? CH2. I will write big so that there should not be any ambiguity for you. So CH2. Methylene. This is the methylene moiety. Next, phenyl. What is phenyl? Already you wrote. I have told benzene. Dimethylene, right? Methylene and diphenyl. Diphenyl means two phenyls. And diisocyanate. Diisocyanate means two isocyanates. What is isocyanate? N double bond C double bond O. Here also N double bond C double bond O. So n number of molecules of methylene diphenyl diisocyanate reacts with n number of molecules of ethylene glycol. What is the structure of ethylene glycol? Already I have explained to you. OH, CH2, OH, CH2, OH. Now, n number of moles of methylene diphenyl diisocyanate react with n number of molecules of ethylene glycol, resulting in the formation of polyurethane. So both undergo polymerization. Now what happens during this polymerization? What you will do? You will literally remember or memorize the structure of the polymer unit. Now do remember that during the polymerization between methylene diphenyl diisocyanate and ethylene glycol, hydrogen transfer takes place from OH moiety of, that is hydroxy. OH means what? Oh, this one. Hydroxy moiety of ethylene glycol. Hydrogen transfer takes place from hydroxy moiety of ethylene glycol to the nitrogen of isocyanate. So this is what exactly happens. So what is happening, students? During the polymerization between these two monomeric units, hydrogen transfer takes place from hydroxyl groups of ethylene glycol. Wherever the hydroxyl group is there, the hydrogen will be lost from that particular hydroxyl group, and that hydrogen will link to the nitrogen of isocyanate moieties of methylene diphenyl diisocyanate. How it happens? Let us see. So how it happens is, among the oxygen and hydrogen, which is electronegative students? Oxygen is electronegative. Already we know that. Oxygen is electronegative. Since oxygen is electronegative, the electronegativity means what? Capacity or ability to gain the electrons. That will, the electronegative atom pulls the electrons from the adjacent atom. Now what happens is, now as the oxygen is most electronegative, it pulls the electrons from hydrogen atom. Whenever it is pulling the electrons from hydrogen atom, it is gaining the electrons. Now what is the charge of the electrons? Negative. So since the charge of the electrons is negative, as the oxygen is gaining the electrons, oxygen will get the negative charge. And the hydrogen is losing the positive charge. So losing the electron. It is losing the electrons means what? It is losing the negatively charged particles. Since it is losing the negatively charged particles, it will get the positive charge. On it. So same thing here also, minus, plus. Now, among the nitrogen and carbon, which is electronegative? Nitrogen is electronegative. So since nitrogen is electronegative, what happens is, the pi electrons, double bond, right? So pi electrons will move towards this nitrogen. That is, double bond is shifting towards, the pi electrons are shifting towards the nitrogen. So since the double bond is shifting towards the nitrogen, the electrons are shifting towards the nitrogen. So nitrogen will get the negative charge. Now nitrogen is getting the negative charge. Now what happens? The same thing here. So pi electrons will move towards the negatively charged nitrogen. So nitrogen gets the negative charge. Nitrogen gets the negative charge. Now nitrogen, that is isocyanate moiety, whatever the nitrogen of isocyanate moiety of methylene diphenyl isocyanate is getting the negative charge. Since it is getting the negative charge, it will abstract the positively charged H plus ion, which is present in the hydroxy moiety of ethylene glycol. So now what happens, students? What you need to do? Where is the change? The change is only at the nitrogen of isocyanate moieties of one of the monomer unit, that is methylene diphenyl diisocyanate, and the change is taking place only at hydroxy moiety of ethylene glycol. The remaining is 1IC. Now you have to write the structure of the resulting substance. What is the resulting substance? Polyurethane, which is a polymer accordingly. So is there any change over here, students? There is no change, because the change is only at the nitrogen double bond. Now next, what is there? C is there. Next, what is there? The pi electrons are shifted towards the nitrogen. So pi electrons are shifted means what? A double bond converts to single bond. Next, nitrogen. Now what is happening, students? Nitrogen, it is becoming electronegative, that is the minus charge is present on the nitrogen. So since minus charge is present on the nitrogen, it is abstracting the H plus ion from hydroxy moiety of ethylene glycol. So N minus abstract NH, that is N minus abstract H plus. Accordingly, it converts to NH. Next, is there any moiety in this phenyl group? There is no change in the phenolic moiety. Is there any change here? CH2? There is no change at CH2. Is there any change at phenolic moiety? There is no change in phenolic moiety. Is there any change here? Yes, N minus is abstracting H plus of hydroxy moiety of ethylene glycol. It is converting N, wherever the N is there, it will convert to NH. Now pi electrons are shifting to the nitrogen. So since pi electrons are shifting to the nitrogen, the double bond converts to single bond. The double bond converts to single bond. So is there any change at the C double bond O? There is no change. But what I will do is, in order to join these two moieties, whatever the C double bond O moiety is horizontal, I will write it vertically. That is C double bond O. Now what is happening? Hydrogen has been lost, students. What is left? Only oxygen is left. Right? So next, is there any change at the CH2? There is no change at the CH2. Is there any change at the CH2? There is change at the CH2. There is no change at the CH2. Now is there any change at the hydroxy moiety? Definitely there is a change, because hydrogen is being lost. Only oxygen is left. This is our polymer. Now do remember that this particular NHC double bond OO, NHC double bond OO, NHC double bond OO. So this particular NHC double bond OO is urethane linkage. So as it is the polymer, it comprises n number of urethane linkages. So it not only contains the single urethane linkage, it comprises n number of urethane linkages, because it is a polymer. So since it comprises n number of urethane linkages, the polymer, which is so obtained by the combination of methylene diphenyl diisocyanate and Yeah, that is ethylene glycol is polyurethane because n number of urethane linkages will be developed in the polymer which is so obtained during this particular polymerization between these two monomeric units. I hope you understood this. So please do comment on the video, students, every video, because that will encourage me to do more and more videos. You deserve. Thank you. Thanks for watching.